Systems Lab. So today we are going to demonstrate how a multimeter measures resistance and current in two different modes. Here we have chosen Bartek M928. Both the multimeters are same. So this multimeter is going to measure the resistance, whereas this one is going to measure current. You can see it is connected in emitter mode. So first I'll explain you how multimeters measure resistance. Say you have some resistance under test. Okay, you simply connect it to multimeter. Multimeter uses current. This is your multimeter, and it typically uses current to generate a voltage drop across resistance under test, and it measures the voltage across the resistance and converts that analog voltage into digital, and then from the known value of current and voltage you can find out resistance by simple Ohm's law. So here RT is simple V by R. This is how a multimeter does it. Now what happens in case of current sensing mode? Say you connect a multimeter in series. Say you have a multimeter which is connected. This is the circuit, and ideally the internal resistance of the multimeter should be 0, and ideally the drop seen by the circuit should be 0, but it does not happen. Multimeter uses a very small value of resistance to sense this current. The current passes through this, and there is some drop across this resistance, and this resistance is of course known, so you find out I is equal to V by R. V is sensed internally by A to D converter, and then by the known value of R and V, this formula is used to find out what is the value of current. Now in this experiment what we are doing, we are simply connecting two multimeters. As you can see here, these two multimeters are connected, which means we are simply connecting this multimeter. What essentially means that we are not using any resistance. Now what it means, the current of this particular multimeter, let us call it multimeter 1, which is this one, which is in resistance measuring mode. This directly goes to the multimeter 2. So it goes here and here. So which means now when this multimeter measures resistance, it will measure the internal resistance of multimeter 2, and if this multimeter measures the current, it will measure current of 1. Okay, so now let's start the experiment. So now let us start with multimeter 1. What typically happens, that in order to measure a smaller value of resistance, the current value has to be higher. So this multimeter is in 200 ohms mode, which means that here it should use maximum value of current in order to find out the resistance. Now let's see. So we have to focus here in order to see how much is the current sourced or synced. Okay, yeah. So here we see it is 140 micro ohms used by this particular. Now let's draw the table for multimeter 1. Okay. Here we have, say, mode, and here we have current. So when you have 200 ohms, it uses nearly 140 microampere. Now let's move to 2K and see. Yeah, so it has to be lower than this, which is 116 microampere for 2K. Let's go to 20K, and you can see it is 38 microampere. Go to 200K, and here let's change. Here it is 4.4. 2 mega, and here you can see it's 0.5 micro, 20, and it's further it is 0.04 micro, and I don't think we can measure the current below this, and anything will be spurious. So let's go this, and it is measuring 2, which I believe is not the right one. Okay, so here we are done with this table, and we know what the magnitude of current this particular multimeter uses in these modes. Now let us come to this one. Okay, and now we have to find out what is the internal resistance here of this multimeter by reading this particular value. Okay, so now this is in 20 micro, and here we must be having the maximum value of internal resistance. Let's see how much it is. Okay, here it is. Okay, so let's draw the table. Here it is mode, which is R, and here current measurement mode, and we have to find out resistance, which is internal resistance. Now in 20 micro mode, this is 10 ohms is the internal value. Okay. Let's go to 200 micro. So it is 1 kilo ohms, 2 milli, it's 100 ohms. It's 10 ohms. It's further small. So 200 milliampere, it is close to 2 ohms. So in 2 ampere mode, it is nearly 1 ohm. So what it means that if you are measuring current in, say, this range, then the internal resistance of the multimeter is 100 ohms, which comes in series along with your circuit. And when you are measuring resistance from a multimeter, say if your resistance range is within 20K, then the multimeter uses current of magnitude 38 microampere in order to drop, in order to sense the voltage drop across that particular resistance. And this is also one of the reasons why you cannot measure resistance value while your resistance is connected in a circuit, and the circuit is already active, which means that resistance is drawing. So you try to measure resistance value through from this particular multimeter, which means that there will be a clash between multimeter current and the current which is already flowing through the resistance. So this was all about uh, resistance and current measurement mode of the multimeter. There is a typo here. It's RT is V by I, not R. Okay. We repeated the whole exercise of measuring current and resistance with the help of other high-end multimeters. What we did when we are testing this particular multimeter, we are measuring current of this multimeter. We used other high-end multimeter for measuring current, and we found that the more precise current value in 200 ohm is 160, and similarly in other modes the values are in red are the more precise one. In 200 kilo ohms, mega ohms range, the current is more or less same what we had measured earlier. We repeated the same exercise with this as test multimeter, and we used other high-end multimeter to measure the resistance values. All the values are fine except these two ranges. In 200 milliampere range we are getting 1.5 ohms, whereas for 2 ampere range we are getting nearly 500 milliohms of resistance. Hope you liked our exercise.